Hello grade 11s. So today what we're going to do is we're going to go over some of the corrections from the previous exercise that I gave you. So I gave you from number 7 up until number 11. So we're going to go over the corrections for that first. Okay, so the first question starts off by saying the battery in the diagram alongside has negligible internal resistance. Okay, the reading on A1 is 1.5 amps. Okay, so this was given in the question, but be careful because it's not given in the diagram. So don't just skip over this part because it gives you valuable information that you're going to need. So if I go here to A1, then I'm just going to put 1.5 amps. Okay, so that I also know exactly what the reading is there. So it says to calculate the reading on V2. Now V2 is the voltage that is across the parallel circuit. Okay, so don't get overwhelmed by the fact that this looks like that and it's not in the traditional V format. Okay, this is still measuring across both the 12 and it's measuring across this resistor as well. But wait a minute, won't that now affect our results if it's recording? How do we know then if it's recording from this side or this side? Surely that will affect the results. No, it won't, because remember that the voltage is the same in a parallel circuit. So the voltage here is the same as the voltage here. So this is going to give the reading for both of them because they would both be the same. Okay, so hopefully it was easy enough to see that you can use Ohm's law to calculate V because you have the resistance and you have the current through this part. So you could just simply say, well, V is equal to I times R, but the current is 1.5 amps multiplied by the resistance, which is 6 ohms. So the final answer will be 9 volts. Okay, so don't forget to just include it into your question as well, into your diagram. Okay, then 7.2 says to calculate the reading on ammeter 2. So ammeter 2 is here in the circuit. It's important to take note that ammeter 2 is also going to be the total ammeter reading. Okay, so that's quite an important fact in order for us to know. Now, if we look at this question, we notice that, okay, we don't know what V total is. So trying to use I total is equal to V total over R total won't work because we don't have V total and we can't have two missing variables. Okay, so we do have the voltage here, but we can't find V total because we don't know what the V is here either. And we can't use Ohm's law because we don't know the current. So now we think, okay, well, how else would we do this? Well, we know that in the parallel circuit that the current is going to split. So what that means is it means that the total current that goes into this part of the parallel component is going to split into two. It splits into the 1.5 amps and it splits into an unknown amp. So that's what we can find, because if we find that and we just add them together, we'll get the total current that enters and leaves this parallel component. Okay, it's important to note that voltmeters have incredibly high resistances, so they do not allow for the current to flow through this part. So you don't take into consideration this at all when it comes to where current is flowing. Okay, current won't flow through the voltmeter. So to calculate the reading on ammeter 2, I need to calculate the current that goes through the 12 ohm resistor. So I'm going to say, okay, well, the current is equal to V over R Now, the voltmeter reading is the same as the one above, which is 9, over the 12 ohms, which is going to be 0.75 amps. So now that I know, okay, well, if this is 0.75 amps, then together they would just give me the total current. So I total is going to be equal to 1.5 amps plus the 0.75 amps. Okay, you don't have to include the units when you're calculating. It's up to you. Just make sure that at the end you would give the final reading of 2.25 amps. So we conclude our statement and we say, well, therefore A2 is 2.25 amps. Okay, don't forget to conclude the statement, okay? It's asking you to give the reading on A2, so show that the reading on A2 is this. Okay, don't be lazy, okay? You must show that you understand exactly what you are answering. Okay, so now let's have a look. It says 7.3 is to calculate the reading on V1. Now V1 is the voltmeter here. Now I know that the total current is 2.25 amps, which means it will still be 2.25 amps here as well. So then it's quite easy to calculate the reading on V1 because I just have to use Ohm's law again. So I would say, well, V is equal to I times R. The total current is 2.25. The resistance is 18 ohms, which will give you 40.5 volts. Okay, so that would be the reading on V1. Then 7.4 says to calculate the EMF of the battery. Now the EMF of the battery, for now, we understand it as the total volts. Okay, that's what EMF means in our case. So all we have to do is we have to figure out basically what is the reading on V3. That's basically what it's saying. So I'm going to say, well, the EMF would equal to the 40.5 volts that goes through this one, plus the volts that go through that one, which is 9. So if I add all the volts together, I should get 49.5 volts. So that would be total voltage, which is just EMF. Okay, so don't get confused. EMF is not, it's not a concept that you have to worry about right now. Okay, it just means total voltage. Okay, then 7.5, the charge that flows through the 6 ohm resistor in 2 minutes. Okay, so now this is talking about charge, which is C, Q for coulombs, right? Q, charge measured in C coulombs, and it's giving you time. So now that has to do with the current equation, doesn't it? Because the current is equal to Q over delta T. So they want to know what the charge is. So technically charge is equal to I multiplied by delta T. Now if I go to the 6 ohm resistor, I see, oh, but the current that goes through there is 1.5 amps. So I'll just put that in. 1.5 amps multiplied by 2 minutes. Now, do you just put 2? No, you don't, because time is measured in seconds. So be careful of that, because you will lose lots of marks there for not converting. Okay, you have to convert to seconds. So it'll be 2 multiplied by 60, which is 120 seconds. So you put 120, and that's going to give you a total of 180 coulombs. Don't forget the unit. Okay, please be careful of this. Do not make this mistake, because you will lose the marks, and it's a silly mistake. Okay, time is always measured in seconds. Always, in both physics and chemistry. Okay, then 7.6 talks about the energy delivered to the 6 ohm resistor. So now it's talking about the energy. Now the energy is the work. Okay, so the work equation uses voltage. So that's what I need to use. I need to say, well, the voltage is equal to the work over charge. So work is then voltage multiplied by charge, which is technically, I know the voltage through the 6 ohm resistor was 9 volts. And the charge, I just calculated to be 180. So the total work is going to be 1,620 joules. Okay, again, don't forget the unit. Okay, then question 8. It says, the battery in the following diagram has negligible internal resistance again. The switch S is closed. Okay, so S is closed, very important. So 8.1 says, calculate the total resistance of the parallel combination. Okay, so they want to know what is the total resistance here. So the parallel combination is equal to 1 over 6 plus 1 over 12 plus 1 over 4 all to the power of negative 1. Okay, then you just put that all in your calculator and you should have got an answer of 2 ohms. Okay, I know that if you look the way you might have done it before is you can also say, well, if you look at the equation on your formula sheet, it also says 1 over R parallel is equal to 1 over R1 plus 1 over R2 plus, and then so it continues. So you can also do this method, it's perfectly fine, by saying 1 over 6 plus 1 over 12 plus 1 over 4, and then you would get 1 over 2, and then you would have to swap it around to get 2 over 1, which is 2. Okay, it's really up to you on which one you want to use. I just find that the way that I do it is just a way to avoid forgetting that you have to swap it around, and it's not a half but rather it's 2. Okay, so either way is perfectly fine. I just use this one. Okay, so the total current in the circuit. Okay, so I already know the effective resistance for the pink part that I've highlighted. So they want to know what the total current is. Okay, so let's have a look and see. Well, I do know that the total voltage is 15 volts. And I see, oh, and I'm given the resistance of the lamp, which must mean that I can calculate total resistance. So there we go. I can say, well, I total is equal to V total divided by R total. Now the V total is 15. The R total I don't know, but I can find it. I can say, well, it would equal to the parallel component, which is 2 ohms, plus the 1.5 ohms, which would be 3.5 ohms. So 13 divided by 3.5 is going to be equal to 4.29 amps. Okay, that is the reading on the ammeter, the total current. Then it says, what is the potential difference across the 12 ohm resistor? Okay, so they want V on the 12 ohm resistor. Let's have a look. Okay, so let's think. I've already, let me put in the total current, which we just found to be 4.29. Okay, so first of all, we notice that we do not know how much current each one gets. Okay, we know that this is the total, but we don't know how it's going to split. Okay, furthermore, we don't know the voltage over either one of these, so we can't use that voltage here. However, we do know what the overall voltage is going to be total if we calculate it using the resistance here and the current that goes in. So remember that this, if I connected a voltmeter here to measure across this entire portion, it's measuring the voltage using the current that sits here going into this resistor, and just because it's parallel doesn't mean that I can't now find the effective resistance, which I just found to be 2 ohms. So I can use that to my benefit to find the voltage. So I can say, okay, well, therefore the voltage is equal to I times R. The current is going to be the 4.29 that I just calculated, multiplied by the effective resistance, which is 2. Okay, we're not using the 12 yet because this isn't the current that goes through the 12 ohm resistor. I don't know the current that goes through the 12 ohm resistor, but I do know that 4.29 amps is what's going to go through this entire thing, which I found to be 2 ohms. So if you calculate that, you will get 8.57 volts. Now 8.57 volts is going to be the same as the volts that goes through each one, right? If it's 8.57 volts through the one resistor, it's the same for all of them because that is how it works. So you can say, well, therefore the voltage to the 12 ohm resistor is equal to 8.57 volts. An alternative method that you could have used, which is also acceptable, is that you could have said, well, in order to calculate the voltage that goes through this here, I can calculate the voltage through here and just subtract it from the 15. That is also fine. So if you did that method, you would have first found the voltage across the lamp, which would have been the total voltage times the resistance of the lamp, which was 1.5, and you would get 6.44. And then you would have said, well, then 15 volts minus 6.44 volts is equal to 8.56 volts. So therefore the V on the 12 ohm resistor is 8.56 volts. Okay, that's also acceptable. You'll get the full marks even though the answers are not exactly the same. Okay, I'll see the method and then I'll know which one you used and accept both answers as correct. Okay, so 8.4 now says the charge flowing through the battery if it supplies 1080 joules of energy. So again, it's talking about charge, which is Q, and it gives you energy, which is W. So it wants to know the charge flowing through the battery. Now charge is in two equations, right? It's in the current and the voltage, but because they give work, I'm going to start with the voltage equation. So it says the charge flowing through the battery. So do I know the voltage of the battery? I do. It's the same as the total voltage, 15. So I can say, well, then 15 is equal to the work, which is 1080, divided by Q. So therefore Q is just going to be equal to 72 coulombs. Then it says calculate the time it takes for the charge in 8.4 to flow through the circuit. So time has to do with the current equation. So it says current through the battery. The current then is going to be the total current. So 4.29 is equal to the charge I just found over delta t. So therefore delta t would just be equal to 16.78 seconds. Okay, so it's important that you use the equation. So make sure that you have a formula sheet with you when you're answering these questions, otherwise you're going to struggle quite a bit. Okay, then let's have a look at question 9. So question 9 says, okay, the battery again has negligible internal resistance, switch S is closed. The current through the 8 ohm resistor is 0.5 amps. Okay, so they told you information, but it wasn't in there, so we'll just make a note here that the current going through here is 0.5 amps. So it says calculate the current through the 16 ohm resistor. So it wants to know the current that flows here by the 16 ohm resistor. Okay, so let's have a look and see what else we are given. So you might find this to be a little bit challenging, right? But something that you must remember is that the current divides in the opposite ratio to the resistors. So that's a little point that I actually would like to make here, is that current divides in the opposite ratio to the resistors. Okay, because you are not given anything else. You don't know anything about the current of any part of the circuit. You don't know the voltage. You don't know anything. So you have to use the ratio that it splits, because you do know how much goes through the 8 ohms. So that obviously is the only given information you have. So that is the information that you have to use. Okay, so if we have a look and we see, okay, so if it's going to divide in the opposite ratio, if I think about the ratio 8 is to 2, I mean 8 is to 16, sorry, you will have 1 is to 2 because you would divide both sides by 8. So that means that because current divides in the opposite ratio, now this is the key here, the opposite ratio, because you might look at this and you might say, oh, so if there's 0.5 amps through the 8 ohm, then it must be double. But it doesn't work like that, because it is the opposite ratio. So it is actually half of what is going through the 8 ohm resistor. Okay, so the current that goes through the 16 ohm resistor is going to be equal to 0.5 divided by 2, which is going to be equal to 0.25 amps. Okay, so just remember that if you can find the ratio for current, then just remember that current divides in the opposite ratio to the resistance. Because remember, resistance and current are inversely proportional to one another. Okay, and if you think about that, it makes sense. The more the resistance, the slower the current is going to flow. Okay, so just remember then that it should make sense that the current that flows through this 16 ohm resistor is less than the current that flows through the 8 ohm resistor, because there's more resistance here. So there must be less current, because current is how fast the charges are flowing. Now, if you have more resistance, the charges flow slower because there's more resistance. If there's less resistance, the charges go faster, which is why the current is more when the resistance is less. Okay, so I'm going to make another note here that the current is inversely proportional to the resistance. And this is only true if the voltage is constant, which it is in this case because it is a parallel circuit or parallel component. Okay, so we take this from that I is equal to V over R, but if V is constant, then we know that I is inversely proportional to R. Okay, so just please take note of that. Okay, so 9.1 is a little bit tricky. Okay, and then 9.2 says calculate the reading on ammeter A1. So ammeter A1 is quite easy now. All you have to do is just add the current. So you would say 0.5 plus 0.25. Which is 0.75 amps. Now remember, if you did not find, if this was an exam and you couldn't find 9.1, you didn't know what to do, what was going on, but you do know that 9.2 just requires you to calculate the current here and the current here, and you just add them together. Then guess an answer here. Okay, don't now ignore everything else. Okay, obviously homework you must understand, but if this was an exam and you had no other choice, then guess an answer for the current and add it here, because remember, it's still going to follow through. Because you can't lose marks here if you know what to do, just because you didn't know what to do in a previous question. Guess and move on. Okay. But obviously, for your homework purposes, you must make sure you understand, because we don't want to guess, right? Guessing isn't the goal here. Our goal is to understand. But just to give you some exam advice so that you only lose a few marks rather than skipping the whole question because you didn't understand one thing. Okay, 9.3 now says to calculate the EMF of the battery. So basically they want V total. So if we think about V total, right, I don't know anything else in this circuit. So I have to then think, okay, well, if I use Ohm's law, I say, well, V total is I total multiplied by R total. So let's see if we can't figure out these values. So let's start with what I do know. So I do know that I can calculate the R for the parallel component by starting off with this part here. So I can say, well, I'll make a note of it. Let me erase some stuff here quickly. So this part here I'm going to call 1, and I'm going to calculate that. So I'm going to say, well, the parallel component is 1 over 8 plus 1 over 16 to the power of negative 1. So if I calculate that, I get 5.33 ohms. Now I can take that amount here and add it to the 20 ohms to get the total resistance on this portion here. So I will say plus 20, which would give you 25.33 ohms. Okay, so now clearly I have a problem, right? Because I don't know what this resistance is here. However, if I notice, so finding R total isn't going to necessarily work for us here. But I have found helpful information now, because I can say, well, I just found what the resistance is here in this part, and I know the total current. I just calculated it to be 0.75. So if I know the current and the resistance, I can calculate the voltage through this part, which is equal to the voltage here. And do you see any other resistors? No, which means that the voltage here is the same as the total voltage, which is EMF. Okay, so if I say that the V for that parallel component is for that part of the parallel component is going to be equal to I multiplied by the resistance, I can say, well, I know the current to be 0.75. I know the resistance I just found to be 25.33. So that is going to give me a total of 19 volts. So then EMF is 19 volts. Okay, again in the test, okay, don't get confused, right? It does clearly here they say resistor R, calculate the reading on ammeter 2. So clearly you weren't supposed to find anything with regards to R2. You must use your intuition and you must think to yourself, well, EMF is the same voltage as it is here because there's no other resistance here. So despite the fact that it is tricky, it's something that you will be able to see easily the more that you practice these types of questions. Okay, so make sure that if you struggled with this question, then go over it again from the beginning. Okay, then moving on. It says resistor R uses 190 joules of energy in 10 seconds. Calculate the reading on ammeter A2. So I have energy, which is W. I have time, which is delta T, and they want the reading on A2, which is current. So notice that current and time are in one formula, but work is in the other formula. So let's have a look and see. Let's write both of them, okay? Don't get confused, just write both formulas. I is equal to Q over delta T, and V is equal to W over Q. But wait a minute. If you notice, surely if I'm talking about one resistor, is the Q's not the same? They would be the same. So now I should use that to my advantage and say, well, I know that the Q here is equal to I multiplied by delta T, and the Q here is equal to W divided by V. So if these two Q's are equal to each other, then these two will be equal to each other. Okay, so there's a lot of maths here that you have to be able to use. You must be able to manipulate some formulas here. Because now I see, oh, well, I times delta T is equal to W over V. So I multiplied by 10 seconds is equal to the work, which is 190, over the voltage. Now the voltage, do I know the voltage that goes through resistor R? Yes, I do, because I know the voltage that goes through here, which is the same as the voltage that goes through there. It's a parallel. So, and I just calculated it, 19 volts. So I would have 190 divided by 19. So you put that on your calculator, you do some calculations, and you would get the total current I to be equal to 1 amp. Okay, so just take note of this. If you wanted to, you wouldn't really be able to calculate the charge, okay, because you are missing information. However, you might have been able to calculate this charge first by saying 190 over 19 and then use this formula. Okay, so you don't have to necessarily equate them like this. Okay, if you did this one first and then found the answer to Q, you can put the Q in the place it is here, divided by 10, and then you would have gotten the current. So it's 100% up to you on how you want to do it. You can do it in one step or you can do it in multiple steps. Either way, it is fine. Okay, so number 10, it says the battery has negligible internal resistance. The reading on the ammeter is 0.2 amps. Okay, so let's put that in, 0.2 amps. Okay, calculate the 10.1 reading on the voltmeter. Okay, so the voltmeter is giving you total voltage, isn't it? Okay, because if you think about it, it's connected over this 2 ohm resistor, but it would give you the same voltage as connected over here. So don't get confused again with this. Okay, all we're trying to do is we're trying to see, okay, how would we find the voltage? Well, I can find the voltage through this part, isn't it? Because I know the current and I know the total resistance. So I can say, well, the R total for that part is equal to 4 plus 8, which is just going to be 12. Then I can say, well, V is equal to I times R, which will be 0.2 multiplied by 12, which is going to be 2.4 volts. So therefore the reading on the voltmeter is 2.4 volts because they are in parallel with one another. Okay, just because it's going up doesn't mean that it's still not in parallel. Remember our definition for parallel. If the battery starts here, the current is going to flow and then it reaches a point where it can go in one direction or another direction. So that is parallel. Don't get confused that there's a resistor at the top and at the bottom of the battery. Okay, it doesn't change anything because the current, think about how the current flows. It's going to go this way and it's going to go this way. That's parallel. There's no difference to that. And if the 2 ohm resistor was here, it's exactly the same thing. So don't get confused. Okay, then 10.2, it says calculate the total current supplied to the battery. So the total current that is supplied to the battery, we're essentially trying to find the current that's going, we know the current that goes through this way, we need to calculate the current that goes through that way. I just found the voltage to be 2.4 volts. So I can calculate the current because I have the resistance. So I can say, okay, well, the current through the 2 ohm resistor is equal to V over R, which is 2.4 divided by 2, which is 1.2 amps. Now, if I take that 1.2 amps and I add it to the 0.2 amps, I will get the total current, which is equal to 1.4 amps. Okay, then it says, what is the EMF of the battery? Okay, the EMF is just equal to 2.4. Okay, it's just trying to trick you to see if you understand. The EMF is just the total volts. Okay, and then the last one, number 11, it says 2 resistors, 7 ohms and 3 ohms respectively are connected in parallel. Okay, so we have 7 ohms, 3 ohms. The cell in the circuit has an EMF of 4.2 volts. And the current flowing through the 3 ohm resistor Oh no, they say the current flowing through the 3 ohm resistor is what? Okay, so make sure, and you can see that I've left space here for myself, but this is a type of question that you must draw. Okay, you can't just guess or just try and visualize it. Okay, you must draw, otherwise you're not going to get this answer. And remember, 2 marks is a lot of marks when it comes to these types of questions, so you can't afford to make mistakes here. Okay, so let's think. Well, if the voltage is 4.2 volts and there's no other resistors, then we know the voltage through this, it's going to be the same, 4.2 volts. So I can say, well, current is equal to V over R. The voltage is 4.2, the resistance is 3. So you'll put that on your calculator and you should get an answer of 1.4. Let me double check. Yeah. So your answer is D. So you had to calculate this. Okay, so please just take note of that and make sure that you draw. Okay, it's not a question that you can just visualize. Okay, and that's the corrections for the homework. Okay, so I wanted to have a look. You would have seen on Google Classroom, as well as hopefully you do have the printed out sheet of the exam questions, the past paper questions that I've taken out. So I'm not going to give you the exam questions from the textbook for now. Okay, that is something that I will do with you as part of an extra lesson when I get back, so that we can see how much you understand and if there's anything that you might be struggling with. Okay, so the exam questions, the past paper questions that I've given you is what we're going to go over now. So I'll do the first one, question 1.5, 1.6 and question 5 with you, and then the rest will be for homework. Okay, so it says, John wants to decrease the resistance of an electrical circuit and has the following options: to increase the length of nichrome, to increase the thickness, or to use a copper conductor instead of a nichrome wire. Which combination of his options would best reduce the resistance of the circuit? Okay, so he wants to reduce the resistance of the circuit. So we ask ourselves, okay, increase the length of the conductor. Would increasing the length of the conductor decrease the resistance if I take the length and I make it longer? No, it wouldn't, because it's going to take more energy in order to go from one side to the other side. So increasing the length will not decrease the resistance. Okay, then the second one, increase the thickness of the conductor. Yes, that would, because there will be more space. So that would decrease the resistance. Use a copper conductor instead of a nichrome wire. Okay, so something that is quite, you might not have known, but copper is actually a very good conductor of electricity in comparison to nichrome. However, if you have a look, even if you didn't know that, number one is invalid. We know that increasing the length wouldn't work. So A has 1, which is wrong. B has 1, which is wrong. And C has 1, which is wrong. So it can only possibly be D. Okay, so just take note of that, that even if you didn't know, right, there's only one possible option because all of the rest have 1, and 1 is definitely wrong. Increasing the length of the nichrome conductor will not give you the right answer. Okay. Then 1.6 says, the maximum work done per unit charge of a battery is what? Okay, so work done is energy. Per unit charge is Q. So when I think about W and Q, I must think of potential difference. But now, is it going to be terminal potential difference or is it going to be EMF? Well, terminal potential difference is just any voltage, right? It can't be these two, so it has to be A or D. But any voltage is calculated by work done per unit charge. So if it was just this part, work done per unit charge, it would be terminal potential difference. But because it says maximum work done by a battery, then it must be EMF. So that means that D would be out and A would be the answer here. Okay, so just take note of that. Okay, then let's look at question 5. It says the circuit below shows two light bulbs, 4 ohms and 5 ohms, connected in parallel to a 4.5 volt battery. Okay, 5.1 says to calculate the effective resistance of the circuit. Okay, so let me see if I can take a screenshot of the picture. Okay, so it says calculate the effective resistance of the entire circuit. Okay, so let's try see make this a bit bigger. So the effective resistance of this circuit is going to be just the two parallel parts. So I'm going to say, well, the R parallel is 1 over 4 plus 1 over 5 to the power of negative 1, which is just going to be 2.22 ohms. Okay, that's the answer for number 1. Number 2, it says calculate the total current of the circuit. Okay, well, I just found the total resistance. I know the total voltage. So I can say, well, total current is equal to V total over R total, which is 4.5 over 2.22, which I just calculated. So that would give me an answer of 2.03 amps. Okay, then the third question says calculate the amount of charge that is passing through ammeter A2 in 10 seconds. So it wants charge Q in 10 seconds, delta T, so that has to do with current. So current is equal to Q over delta T. Now they want to know the charge. So charge is I multiplied by delta T. I know the time is 10 seconds. Do I know the current? No, I don't. All I know is what the total current is going to be. Okay, so now that is going to be up to you on how to figure it out. So first of all, you can say, well, I know that there's no other resistors here, which means that the total voltage here is also 4.5 volts, which means that it's the same here and the same here. So I can say, well, the current that goes through that is equal to V over R. The voltage is the same as the total voltage. The resistance is going through the 4 ohm resistor. So the current there is going to be 1.33 amps. Okay, what you also could have done is you could have said by calculating using the ratios, you could have also used the ratios to split it And you could have said, well, if you know what the total current is, then you can also work out the 4:5 ratio as well. Okay, so moving on. If you are going to now use this current, you're going to put it in the place that we found here, and you're going to say, well, 1.33 times 10 is going to give you an answer of 11.3 coulombs. I think, let me double check. I think I made a mistake here. It's 1.13. So 11.3 coulombs. Okay, if you wanted to use the ratios, you would get a more accurate answer. So I actually think I made the mistake. I shouldn't have rounded off early. So let me go back and change this. So don't round off early. Okay, like I did. Okay, because it is going to give you a faulty answer. It's supposed to be 1.125 multiplied by 10, which in this case gets you to 11.25 coulombs. Okay, I just want to show you the second method is if you wanted to use the ratios for the current. So remember, it's 4:5, and the total current is 2.03. So if you take 4 plus 5, it's going to be 9. But now you have to remember that what happens is that it's the opposite ratio that current splits in. So if it's the opposite ratio, then you would say, okay, well, 4/9 multiplied by 2.03 and 5/9 multiplied by 2.03. So if you want to just do both of them, you can, if you're uncertain. So for this one, you get 0.902, and for the 5/9, you would get 1.1278. Now, there's more current that flows through here, and the more current is supposed to flow through the one with less resistance. So more current, less resistance. So this one flows through the 4 ohm one. So you take the opposite. So this is what I mean when I say the opposite ratio. Okay, and then you can use this same current, 1.1278 here. You would get the same answer. Okay, so you can use either method. It's fine. It will still be the exact same answer. Okay, then the last one says another resistor is connected in series to the ammeter A1. So another resistor is connected in series to A1. How will this change affect the total current of the circuit? Write down only decreases, increases, or remains the same, and to give a reason for your answer. Okay, so firstly, let me just make a little bit more space here so that we can answer on this page. So we need to ask ourselves, okay, what does adding a resistor do to the circuit? So if I'm going to add a resistor here, it wants to know how it's going to affect the total current. So total current is equal to V total over R total. Now, if I'm asking myself, okay, what am I changing? So I want to know, first of all, how this is affected. But I see that, oh, but changing the resistance isn't going to change the total voltage, isn't it? Because the total voltage is still going to be 4.5. But what it does is it does change the R total. So according to my equation, this is question number 4, I know that I is inversely proportional to R provided that V is constant. These are very important. Notice it's 3 marks and they are always asked. Okay, we're always going to ask you how adding something or removing something is going to affect the circuit. So we start with the relevant formula. Okay, you get a mark for this. Now we see, okay, if I'm going to take this resistance, now if you don't know, then just quickly assign a value. Remember, you know that it's 2.2 ohms, this part. So if you added any value here like 2, it would change the total resistance to 4.2. So adding another resistor in series is going to increase the resistance. So you must write that. Adding the resistor in series increases total resistance. Increasing the resistance is going to decrease current. Resistance decreases total current. So therefore the answer is decreases. And you already provided the reason. It's because I is inversely proportional to R, so adding the resistor in series increases the total resistance, and increasing the resistance will decrease the total current. Okay, so that is what you had to say. You can also go as far as to include that current is inversely proportional to resistance. So you either write that they're inversely proportional or you give the formula provided that V is constant. Okay, so that is the answer for the whole of question 5 from 5.1 to 5.4. So if you need to go over this again, if you want to do some of the questions by yourself and try them again, you're more than welcome to. But your homework is going to be to complete the rest of these questions. So it's 1.5 and then question 7 and then 1.6 multiple choice and question 6. Okay, and then that's it. So please make sure that you go over these and you make sure you understand. Okay, all of them are taken from grade 10 past papers, so it shouldn't be too tricky for you to do, but remember it lays the foundation. Okay, so there's 3 parts to circuits. It's Ohm's law, which we've now covered. Then it's the laws that we use with power calculations, which we're going to do now in grade 11. And then next year we'll look at internal resistance. So every time you see a question that says it's negligible, next year it will not be negligible. Okay, so please make sure that you're practicing, go over the exam questions, and yeah, then I'll see you on the next one. Good luck.